Hi, my name's Andy. Welcome back. If you're returning, coding's supposed to be fun, isn't it? Or these videos are supposed to be fun. And Rust is fun. But what's the best type of, like the funnest type of thing to code? Well, games have got to be up there. And what's the best type of game to code? Like simple pixelated games. And on what platform do you want to write a game for that everyone is going to be able to play it? Well, that's the web browser. So let's talk about how we can write Rust code to make like retro style pixelated games that run in a web browser using WebAssembly. And the first bit, we'll just talk about like how to make a project in Rust that then runs in a web browser using WebAssembly. And then after that, we'll make some kind of like little bit of a framework for a game. And then hopefully in future videos, I'll write a silly game and it'll be more fun. Even more fun than this one. Anyway, so stick around if you want to see like the basics of just how to get some Rust code and have it run as WebAssembly in the browser. And then we'll do a little bit of like make a canvas appear in a web browser and have our Rust code draw something on it. Right, so let's go. Right, so prerequisites are you need Rust and you need WASM pack. So let's have a quick look at the WASM pack website. So there's some confusion in the documentation right now. Hopefully, if you're watching this in the future, it will have become less confusing. There's some confusion right now about what you need to get going with Rust and WebAssembly. I reckon I've discovered that what you need is WASM pack, and you need it from this new website where it lives now. So WASM pack is a tool that basically makes it easy to do Rust and compile it to WebAssembly. When you click on install WASM pack, it tells you to run this script without verifying it on your computer. But you can also install it by saying cargo install WASM pack, and it'll build it from source. And then obviously you'll then run that on your computer without checking it. So, up to you. But yeah, so before we start, I've already installed WASM pack. And what that means is I can now do WASM pack new. I'm going to call this WASM game. So make a new project called WASM game. And this is, like, as far as I understand, WASM pack is mostly kind of a thin wrapper over some cargo stuff, but I haven't looked at what. So it's all very rusty. So now I've got a directory called WASM game. And let's have a quick look at what's in there. So it's made as cargo.toml. It's made as some license files, which I'll remove because they're not the licenses I will choose for this project. It's made as a README, which we'll look at in a second. And it's made some Rust files and a file where you can put tests. One of the things it lets you do is write tests that you can then execute in a browser, in a headless browser, and it's kind of all of that's managed for you as well, which is really cool. But we won't be trying that out today. All right, so get rid of those license files. Let's have a look at what's in there. Where should we start? Let's start with the README. So I'll just bring up that directory tree so I can see what I'm doing. And while I'm here, let me just make sure I'm in the right directory in these other terminals that I'm going to use in a second. All right, so the README, annoyingly, it's got like this HTML stuff. And anyway, it basically is a combination of a README you might want in your project and a README about this template that is used to build this project. But yeah, so there's a lot we need to ignore, but the important part here is that we can do WASM pack build. Oh, and here's the thing about if you want to run your tests in a real browser, write some tests, and I guess put them in here. Yeah, this WASM bind gen test is the way you annotate them to say these should run in a browser, and then you can say WASM pack test and say which browser to run it in, and it'll do it. But there are build instructions here, but they're not quite right for us. What else is in here? Right, and then there's, yeah, okay, so we're probably done with this README. It's basically just telling us how to build, so fine. So while we're there, let's just get rid of the readme too. So now if we have a look at what files exist, probably the one we want to look at first is cargo.toml. So this has all been generated for us, very much like when you do cargo new, but with some extra stuff done. So what it's done for us so far is it's added a dependency on WASM bindgen. So that's basically a thing that lets you automatically have the ability in Rust to call functions in your WASM environment, that might be your browser, by just automatically, I guess, binding them. In a minute, we're going to add some more dependencies so we get more of the stuff from the browser with WASM, with WebSys. It's also brought in this console error panic hook thing, which basically means you can tell it while you're running in the browser, if we panic, print something to console error. A couple of other bits and bobs. It's a good idea. I've heard it's a good idea with WASM to set your optimization level to S for size. So basically try and make my WASM small. And I note with pleasure that it's done that for us. No idea why it's chosen 2018 edition, but that shouldn't affect us. So normally I would bump that up to something more recent, but I don't think it matters. All right. So, we've got some Rust code. Let's have a look at the actual Rust code, shall we? So there's this utils, which basically provides this thing to set the panic hook, which again is that thing that when you panic, it will print to the console in the browser. By the way, you actually have to call this function, which we're being warned that we're not calling it, but that won't work unless you call that function. So we'll have to do that in a minute, but we won't do it quite yet. And then you've got some code, and you've got 2 bits. So first thing I'll talk about is this function called greet. So we've got a WASM bindgen annotation on this. So basically what that's saying is make this function available to JavaScript to call. And what this function does is calls alert. So this will make an alert pop up in your browser. But the reason why it can call a JavaScript function is because we've said, please generate a binding of this function. It says extern C, which is really confusing in this context because this is actually saying there is a JavaScript function called alert that exists, and I would like you to allow me to call it from in my Rust, which is why we're allowed to call it here. All right, so preambles aside, let us build our code. So the way we do that is WASM pack build -- target web. If you don't say -- target web, it will make you something that's suitable for running in Node.js, which may be useful at some points, but it's not useful for us right now. So it's going to go off and build, grab a load of dependencies, and then it's going to build our code. And it's put the built code inside pkg. So if we have a look at what it's done, it might be instructive. So it's made a package.json file, which is more useful for Node.js stuff, not particularly interesting to us. And it's made various like TS files. Just have a look what we've got in here. Yeah, it's made these two TS files. So they have type information. This is TS for TypeScript. So they have type information about the stuff that's generated, but the stuff so we won't look at that again, but that's, if you're doing TypeScript coding, it's very useful to have these available so that you can see what, like your autocomplete in your editor and stuff will work because anything you're using has a TypeScript definition. But the thing we're going to look at is that there is a function, it's created a function called greet. So remember in our Rust, we had a function called greet and we said, please create us a function we can call from JavaScript. Well, because we said that, it's created this function called greet. And a whole bunch of stuff. There's not that much. Anyway, so other stuff that we're not going to look at. But right, I thought we were doing WASM, but this is JavaScript. Well, why is it JavaScript? Because in order to be able to use this stuff conveniently from JavaScript, you need this JavaScript function called greet, and then it handles actually calling another function called greet inside the WebAssembly, which it is somehow, in some way that we're not thinking about here, made available. And then our actual WebAssembly is in this file. This is a binary file. So that is where our Rust got compiled and turned into binary WebAssembly. You can see some symbols in there, but there's a load of binary stuff. So the actual Rust code that we wrote, which is in here, I guess doesn't do much, just says call a function. But if we did some arithmetic or something in here, that would get converted into WebAssembly that is then stuck into this .wasm file. And you can see there's more type definitions for the stuff that's in the WASM file. All right. So now we've written some Rust code. Well, actually it wrote some for us. In a minute we'll write some. And then it's generated this wasmgame.js file. But how do we actually run it in a browser? You can't run a JS file in a browser. You can't run a WASM file in a browser. The only thing you can run in a browser is HTML. So we're going to need to write some HTML. So the way I tend to organize my projects when I'm doing this is I have Rust source code in a source directory, tests in a test directory, and then the way WASMPack does it is it generates its output in a package directory. So I think we need two more directories to make this work nicely. First, we need a place for source code that is not Rust, but is like stuff we're handwriting. And it's going to be HTML and CSS, basically. A bit of JavaScript in the HTML. So I make a directory called www for that. And then also I need, you might think that like the package directory is in some sense a bit like the target directory with normal Rust code, where all the binaries go. But actually the package directory only contains stuff that's generated by WASMPack. And if we start mixing other stuff into there, I think it's going to get confusing. So what I do is I make another directory, which I call public, which I think is a hangover from the fact that in GitLab, at one point, in order to make a website, the directory had to be called public. So anyway, now it's called public. It could be called HTML or I don't know, something better than that. But anyway, let's call it public because I can't think what else to call it. So let's put some HTML in www. So I guess we should start off with just like the simplest possible bit of HTML. So let's make a file called index.html. And let's make like the simplest HTML document we can think of, which looks like this. Because if you don't have a doc type, what are you doing? And I guess we don't need any of this, right? We could just, an HTML file can just be like, just some text and that will show up in the browser. So let's make it and just say some static text here. So we made an HTML document. No WASM, nothing like that. We just want to get that to display in a browser. So what we're going to do is we're going to go to this terminal that I have ready and we're going to cd into public and then we're going to use Python because that's the most convenient thing to do. So for this you'll need Python 3 installed, but if you don't want to install Python, feel free to like make a little Rust web server or use some other web server that can just serve up files from this directory. So when I launch that, Python makes an HTTP server that is listening on port 8000 on the local machine, and it shows you whatever's in this public directory. Now, there's nothing in this public directory. So when we go to 000:8000, it shows us a directory listing with nothing in it. I guess we should probably have the console open on this page because we'll want it later. All right, so there's nothing in it, but we wanted an HTML file to go in it. Not sure why Python is. Yeah, the browser asks for a file called favicon.ico and the Python server is saying it doesn't exist. All right, so we made an HTML file, but it's not actually getting copied into public yet. So the way I normally handle this is I make a makefile. And what's my makefile going to look like? So it's going to have just one job at the moment. We'll probably have So when I type make, I want it to, so by the way, you'll need to install make for this bit to work, but you can do this another way, right? All it's doing is copying some files around and building the code. So build the code the way I already done. So that builds the WASM. Make sure that the public directory exists, and then copy some stuff. So it's going to copy everything that's in www into public. I guess that'll do for now, and in a minute we'll do some more. So when I type make, now there's some stuff in public. Index.html is in public. So when I go back to my browser and I refresh, now because that HTTP server is sitting there still serving any files inside that directory, and now there's a file, I put this index.html in the directory. Now when I refresh the browser, I see that HTML page. So far things are working as we'd expect. Notice this error because it's looking for this fav icon, which doesn't matter. That's like the little icon that appears in the top of the tab if you have it. All right. So not very interesting so far because there's no WASM happening. So let's have some WASM happening well, what are we going to do? We don't need any CSS yet. Just looking at notes. Apologies for the inconvenience. All right, so we're going to have a script tag, and it's going to be script type equals module. This is the way I've found that makes it work best. There may be another way. And what we do is we import a couple of things from that wasmgame.js. So if we have a look in public, oh, well, no, it's not there yet, but in a minute it's going to be there. So basically this wasmgame.js file that we looked at before has some stuff in it that we need to import. So in JavaScript, there's a default import, which you get like this. And, this is called greet. And then we're also going to import that function, which we saw defined, which was called greet from wasmgame.js. And that's not yet in the public directory, so in a second we'll copy that into the public directory. Now what we're going to need to do is call init. Now we're always going to need this bit. It does some setting up, I'm not sure what. And then we're going to call the function greet. So the init function is async, so we have to do this await thing here. And then we're going to call this function greet. So all of this, by the way, is in a script tag that's just at the bottom of the body, which I was reading when I prepped for this, means that any code in here can assume that the stuff in the body already exists in the page. So if we make any assumptions about tags and things existing higher up in the page, apparently we're allowed to do that if the script tag's at the bottom. So we'll take that on trust. So now we've got some JavaScript code which basically says, you generated me this .js file. We'll go get some functions from in there. We'll call the default one init, which just sets things up in some way that I don't know. And then we'll also grab one other function from inside wasmgame.js, which is this function called greet, which we saw in there, and then we call that greet function. So this is just enough JavaScript to bootstrap us that all the work will then be done in WASM. Okay, so for this to work, we need to copy some files, not just out of www, but we need to copy some of these things that got generated inside here, inside package. So what we need is star.js, star.ts, and star.wasm. I could just do star, but then it would copy some stuff that I don't necessarily want, like this package.json. When I did this before, there were more files in there because it was copying the README file in there and stuff, so I didn't like that. So I made it specific. And then I tried to do some clever bash syntax so that these three items could just be one item. And it didn't work, probably because it's makefile instead of bash, or I don't know. So, sorry, I'm just typing it out 3 times. Maybe you don't care. Anyway, when we type make now, and we look at what's in public, now there's a load more stuff in public, including wasmgame.js, which is the thing we told it to import. So now this import line that we've created here should work. So let's try it by refreshing in the browser. And look, our alert popped up. So this test code that we wrote in Rust is now executing in the browser. We can have a maybe look at the debugger and figure out what's going on here. So yeah, the debugger shows us various files that are kind of available to us. I don't know why those other files, the _bg stuff and the .ts, well, I guess the .ts file is not relevant. Yeah, I guess the .ts files are not relevant to this debugger. They're relevant to us when we're developing. But yeah, so we can see the JavaScript code that we wrote there, and then we can see WASM game.js there. So all this stuff has been loaded, and this .wasm file is also like loaded in the browser and executing. So our code is executing in the browser. And right now, as far as I know, it's pretty hard to debug code you wrote in Rust that is running in your browser in WASM. There may well be a great way of doing it, but I don't know what it is. But yeah, I hope this serves to demonstrate that we're now running code that's written in Rust in our browser. I guess it would be good to demonstrate that if we change it. How am I going to do this? Something like this. If we change that code, then it actually works. Now we need to pass in a reference to that, because alert takes a reference to a str. Right, so I've changed the Rust code. When I type make, it builds our code with this WASM pack build. By the way, again, this is just a thin wrapper around Cargo, as far as I understand it. It's telling Cargo what target to use to build WASM code instead of normal code. Oh, by the way, we can also just run Cargo build, and it'll build our code as machine code on this machine. So might be a nice way if the unit tests. If you want it to work in both native and WASM, or if you just want to run your unit tests natively, you can do cargo test in here, and it'll build them as machine code and run your tests right there on your machine. So it might be a bit quicker than running them in the simulated browser in WASM. You can do both. Anyway, what was I doing? Yeah, so when I type make, it builds our code, copies all that stuff into public again. So now we can go back to the browser and refresh. And it'll say, hello, 2 equals 2 equals 4. Did I type that wrong? Yes. What I meant to say was 2 plus 2 equals, and then calculate 2 plus 2 and put the answer into here. And without taking some user input or something, maybe I can't convince you that this code is actually running in the browser, but let me assure you that it is. All right, so that's probably enough. If you were here just to see how to get Rust code compiled and running in as WASM in the browser, then you can stop watching now. So we've covered the two main things you need to be able to do. Write a function that is callable from JavaScript but was written in Rust, and call a function that is available in the JavaScript world from inside a Rust function. You need this extern C thing declaring that it exists for that part to work. And both of them have this WASM bindgen annotation, even though in some sense they're opposite, right? This is saying, make my JavaScript function available, and this is saying, I promise you that the following JavaScript function is available so I can call it from Rust. All right, so bye to those people who just wanted to do WASM and didn't want to write a game, and hello to those who are very excited about how can I make like a little framework for a game so I can write simple little retro pixelated type games in Rust that run nicely in my browser. And what we're going to do for that is we're going to use a canvas. So where should we start? I guess let's put a canvas on the screen, and then we'll start figuring out how to draw something on it. So let's go back to our HTML code. Instead of showing some static text, let's make a canvas. And for now, we'll hard code its number of pixels. So this size, width and height here is not CSS, which you'd use for actually changing the physical size on the page of this canvas. This is how many pixels does this canvas have. And even when we scale this canvas to fill the whole screen, it's still only going to be 22 by 22 pixels in the canvas. They're just going to be very big pixels. So not really pixels, you know what I mean. Right. So when we do just that much, and we build again and we refresh, we can get rid of that alert. But now when we look at the HTML page, we can see that this canvas exists. And it's there, it's quite small right now. So what we want really is for it to be in the middle of the page. So let's do a bit more, bit of CSS. So we're going to bring in a CSS style sheet like this. I'm looking at my notes, by the way. All this stuff, I just had to Google for how to do all these things, even though I've done them a million times before. So don't feel bad if you do. All right, so we're going to bring in the style sheet. While we're here, because it's the right thing to do, let's make sure that we have specified our char set, even though apparently for modern HTML, the only legal char set is UTF-8. But it still makes it easier for the browser to render it if it can absolutely confirm that, I think, by finding this. Maybe not. Maybe it assumes it when it sees this. I don't know. Anyway, this is a UTF-8 document. All right, so what were we doing? Not that. Yeah, so what we're doing is we're saying bring in a style sheet called style.css. Now this needs to exist. So let's make ourselves a style.css file. And what we're going to do is just enough CSS to make our canvas fit on the page. So first of all, again, this is stuff that I've figured out over painstaking time, but I'm just going to do it for you. It's going to be easier than watching me struggle with it. This is why I actually prepped for this video, which is a bit unusual. All right, so every element on the page is going to just not have any padding or margin on it. And then we're going to say that the body of the page is a big flex display. It's displayed in the flex style. And it's going to center things. So justify content, center, and align items center. So that just means center things vertically, center things horizontally. And the height of the body, this is important because otherwise you try to center it vertically, but the body is only like 1/10 of the screen high. So it centers vertically within a very short thing at the top of the page. So that's why I need to say that my body is always exactly the height of the page. By the way, this 100 VH means VH is a unit which is like 100th of the height of the viewport. So 100 VH means exactly the height of the viewport, 100%. And then the canvas, we're going to say its width is 90% of the minimum measurement of either the width or the height of the page. And we also, while we're here, going to say, I want you to render our canvas pixelated, which means instead of trying to blur the pixels so that they look nice and smooth, just leave them like completely sharp edged, because we're writing like a pixelated game. We don't want things to look smooth, and actually they'll just look blurry. So please just show the exact pixels. All right, so we've done a bit of CSS. Let's build our code. It's still being served by this HTTP server here, not doing anything interesting there. So if we go back to the browser and refresh, still alerting us, but now there's a canvas which is not big. Why not? That's surprising. What have I done wrong? Oh, I know what I've done wrong. Yeah, okay, good. Some real bugs happened. You wouldn't believe it that I was doing this off the cuff if I didn't make some mistakes. Right, so, yeah, so it's looking, so this style sheet is looking for the canvas by looking for something with an ID of canvas. Now I could just, if I got rid of that, it would be looking for anything that has the tag of canvas in the page, but that seems a bit bad. So how I wrote it was, look for something with an ID of canvas and make it fill most of the screen. And then I didn't give the canvas an ID of canvas. So By the way, is it bad practice to give something an ID that's the same as the tag name? It could be confusing, don't know. All right, so back to our browser, refresh again, still alerting us. But now look, the canvas, you can't really see it because it's currently a white canvas on a white background. But yeah, the canvas is now filling most of the screen. And when we resize, it resizes. So that's the nice thing about using CSS relative units like this. I don't have to write any code that runs when the page resizes. It's still 90% of the minimum of the width and the height of the page. So if I make the page wide, it's 90% of the height. And if I make the page narrow, it's 90% of the width. So, that's nice. And it's just going to smoothly resize. And remember, it's 22 by 22 pixels inside here. All right. So basically our game is going to be just drawing stuff on the canvas. Now, in a real game, you might well want, what I want when I write a real game like this, is a bunch of UI elements that are not just on the canvas. But if you want to go really retro friendly, you can have absolutely everything be just drawn on this canvas. You're going to need a higher resolution than 22 by 22 if you do that. This is pretty small. But yeah, in our code, we can actually change this width and height programmatically, or we could just change it in our HTML. Anyway, so where are we at? We've got a canvas drawn on the screen. We've got Rust code running, compiling to WASM and running and able to call JavaScript functions. What we're missing is the Rust code to draw something on the canvas. And we're only going to, how far we're going to get in this video is, we're going to get something drawn on the canvas. We're going to get a game loop running, and then we're going to stop. So first things first, let us write some code that we want to run. Basically when the page gets loaded. So let's stop having something called greet, stop calling that annoying alert function, and let's have a function called start. And in our HTML, we're going to want to, or in our JavaScript inside our HTML, we're going to want to just call start, and that's all we'll do in the JavaScript. And then everything else is going to happen triggered by running that function. So we've changed the name of the function in the Rust. So if we rebuild, still complaining that set panic hook is not used, but now it's updated our JavaScript. So now when we run, we shouldn't see an error. It stopped alerting because I've stopped it from alerting, but I reckon it's successfully calling that start function. We better make that start function do something, haven't we? First thing we can do is we can, what's it called? We can call the function set panic hook. And because we know start is only going to get called this one time, and that's a good place to call set panic hook, because you only need to call set panic hook once to just say, from now on, if you panic, print something to the console. So I guess we better test that, hadn't we? And actually, I guess what I should say is, what if we don't do this? So if we don't do this, and we panic, and we open it in the browser, then basically something bad happens, but you can't really see what, so it still gets surfaced in some ways to the browser, but it's not useful. If I set the panic hook, hopefully when I panic, it's going to print something useful. Yes, it printed help. Right. So our panic message is making its way into the browser. That's all that's for. All right. So the panic hook's set. Now what are we going to do inside start? Well, what we want to do is draw something onto the canvas. And in order to be able to do that, so far the only JavaScript function that we've called from Rust is alert, which was available to us. But if we want to be able to call stuff to do with the DOM, the browser DOM, then we need a dependency on a thing called WebSys. So in our dependencies section, we need to depend on WebSys, and let's start out with it just done the normal way, and then in a minute we might change it. So let's have another dependency, and we'll just ask for version. Oh well, I guess we don't need anything right now. No, we are going to need something else. Yeah, so we'll go here. Let's ask for version. Now, when I was setting this up, I used version 0388, and we're also going to need some features. So the way WebSys works is everything you might want from JavaScript is its own separate feature. So it's absolutely loads. So for now, let's just ask for the console feature. And that means that inside here, we should now be able to do stuff with console. Like this. We should be able to call the log1 function on the console module. Let's see whether it's going to let us. We might need to... oh yeah, okay, it's recognized it, fine. So we're going to be able to call the log1 function. So basically, if you're familiar with JavaScript, there's this thing called console.log, which prints stuff into that error console that we have on the right-hand side of our browser, or that log console. And log1 is like call console.log with one argument, and there's a log2 if you want to pass in 2 arguments. But notice that we can't pass in an ampersand str to log1. Log1 takes as its argument a JS value. And I happen to know, a reference to a JS value. I happen to know that there is there's a conversion to convert from an ampersand str into a JS value. And it wants a reference to a JS value, so we have to do ampersand. So I spend my time doing a lot of ampersand and then .into to convert a string of some kind into a JS value so that I can log it. Right, so now we've added a dependency on WebSys, and we've asked that this console thing be available. And that means that this module WebSys provide this thing called console, and that means we can call this function in that. I guess console's a module. I guess we can call this function log1 in that module, and when we build it, it will build that new dependency JSSys, and JSSys is a dependency of WebSys, and WebSys is the thing that we used. So it's done all that. It's built our WebAssembly. Now when we refresh our page, we can write a console log, and the log level at which it's written was log. So if we get rid of logs, it's not there anymore. When we click logs, it's there. Anyway, we successfully ran console.log. If we just run console.log here, hi from JavaScript, I guess, then it's going to look very similar, right? Our Rust code has done the same as what I just did here. Okay. So now we've got WebSys. We're actually going to need a bunch of features from inside WebSys. And instead of me constantly swapping back to add more features, I'm just going to copy in what we need. And I'm going to show you a little hint that I think is a better way to do this. Normally, when we do dependencies, our toml is just like key equals value, but it gets really unwieldy when a list gets long, so this features list gets long. So one thing you can do is you can make a new section called dependencies.websys, which is kind of equivalent to saying WebSys inside the dependencies section, so we can get rid of this. And then inside there, we can do key equals value. So instead of having features equals blah like we had before, we can now have like a top level features and then this array thing for this list of all these features and versions. So that might look a bit confusing, but you could have done it. It just would be a really long, annoying line that's hard to break up in toml. This is toml, right? This is not Rust or HTML. Who knew we were going to talk toml as well? But anyway. So anyway, all this gives us is the ability to make a long list of all the things from WebSys that we want to have available. So if I run the build, it'll take a little while just to build them. And some of these are going to become immediately obvious why we need them, and some maybe a bit later. Maybe we don't need image data anymore. I think I changed my mind about that. All right, well, we won't let that worry us for now, but yeah. Like, one of the dangers of this is that you can add stuff and then realize it. Like, never notice that you didn't need it. I think I'll get rid of that. See how it goes. Okay, so that means I need to rebuild. All right, so now we've given ourselves a bunch of the features from WebSys. So now these are basically, most of these things are named after exactly the name of the thing in JavaScript that we want. So for example, document is a way of getting hold of the document in the DOM, in the web browser. That document thing. So now that we've got document available in our Rust code, we can do something like, instead of logging to the console, maybe we can add something to the actual document. Can we do that? I think we probably can. So let's get hold of the document. So, whoops, that is wrong. I'm typing in the window you can't see. So, well, we need to get hold of the window first. So the way this works is we call this function called window, and then we just unwrap, like for some reason it might fail, but we're just going to assume it's going to pass. And now it should tell us that window doesn't exist, right? So then we can bring in window from WebSys. We won't use, well, yeah, we'll leave console. Yeah, console's fine. All right, so we've got hold of the window, and the window contains a document. So now we can say document is window.document. And again, we'll unwrap it. So the reason we've got these unwraps here is that window returns an option. So basically, with a lot of this stuff, the Rust doesn't necessarily know what environment we're in, and therefore doesn't know whether we're in an environment which has a window, and the Rust doesn't know whether there is actually a document in the window. So we get the possibility of these things going wrong. And it might well be sensible for us to put an expect here to say couldn't find window or something like that, because then if that ever does go wrong, we'll see it. But when I did that, when I was preparing it, got really noisy. There's a load of expects. So I think if you're writing production code, you probably want to put an expect in here, even though you think it will never happen. But I'm putting in unwraps just so we don't fill our whole screen with just expects. Okay, so now we've got a document where there's things we can do. So we could create a tag. So maybe we create a P tag, which stands for paragraph, in our HTML page. And then we can say we need to unwrap that as well, because that could go wrong, or I guess, could it go wrong? Yeah, so I guess that would go wrong if we don't know what a P tag is, or no, I don't know why that would go wrong. Does it say? No. All of this stuff just refers you to the documentation on the Mozilla website, which, by the way, is an excellent documentation site about how to use JavaScript and CSS, and in this case, the document object model, which is where these methods are from. So in JavaScript, all the stuff would be called create element like this and similar. But in Rust, in WebSys, it's all been translated into a more Rusty style. Now, what you get back from create element is a result, but which we're just unwrapping. By the way, if it goes wrong, it gives you just a JS value of some kind. But if it goes right, it gives you back an element. And we happen to know that it will actually return us a P element, but we're not going to worry about that. Element is fine. We're going to set the... Can we set the inner HTML? Yeah. We're going to set the inner HTML of this paragraph to hi inner P. Is that going to work? Okay, I'm making this up on the spot. This isn't part of my plan, but I think it's working. All right, so let's refresh the page again. And that didn't work. Oh, I know why it didn't work. Okay, so I missed a thing. So I created an element, but I haven't actually added that element to the document. So now if I say document.append child, I think is going to be what it is. Maybe this. Yeah. And again, that could go wrong, so you should handle that error. Recompile the code, back to the browser, refresh, and it failed. Okay. I'm appending it in the wrong place. See, this is why I shouldn't do things off the cuff. But yeah, instead of appending a paragraph to the document, I need to look for the body of the document. Because every HTML document has just one thing in it called body. I mean, this body is exactly what we saw inside index.html, right? This thing is the body. And we're saying, go find me that body. And that's the thing that I want to call append child on to add this paragraph that we created to the body. So I'll basically add it below this other stuff that's already in the body here. So let's try that. This time it's going to be fine. Hey, look, hi in a P. So that's in a weird place because the canvas is taking up most of the page, and then we've got this paragraph that we've added here. All right, so that was just demonstrating that now that I've got WebSys with various dependencies set up, I can manipulate the DOM. I can do stuff. So what I want to do is to do stuff with that canvas. So let's get rid of this whole paragraph that we're creating, and let's do stuff with the canvas. So the first thing to do is get hold of the canvas. So the way we would write this in JavaScript is we would say document.getElementById. So we can do exactly the same in Rust, but with different casing. So we say document.getElementById, and the ID of the canvas is canvas, which again I said might be confusing. And then we unwrap it because that might not exist. So in this case, we really should handle this error, right? Because maybe the canvas element really doesn't exist, even if just because we messed up our HTML and changed it in some way. So we should handle that error, but I'm not going to do that. And then what I'm also going to do is I'm going to do a conversion, right? So I happen to know that when we get hold of this element whose ID is canvas, its type is going to be a canvas, or rather an HTML canvas element. But I can't just say like the type of this is HTML canvas element. I need to call it like essentially the equivalent of into, and in WebSys that's called din into, and that basically says if the type of this thing that you got back from getElementById is matching this, is HTML canvas element, then return it as okay, that type. Otherwise, return an error. So again, we've got an error to handle here, and again, this error could actually happen if for some reason you had an element in your document with an ID of canvas that wasn't a canvas. So both these errors actually need handling, but we're ignoring them for our fun test. And then the way, so then things get a bit complicated, not because of anything to do with Rust or WebAssembly or anything like that, but because the way you draw on a canvas is you get hold of a context, and then once you've got a context, you can draw on it, and then when you close the context, then your drawing kind of gets committed. So the way you get hold of a canvas is you say context is you say canvas.getContext, and then you have to say what type of context you want, and that could be like, do I want to be able to do OpenGL operations on it or whatever? So I just want a 2D context, and then that might fail, so I'm going to unwrap it. Or it might succeed, but you don't actually get given a context, which again could definitely happen because someone else was already drawing on that canvas at that moment, that kind of thing. And then again, I'm going to use din into to get it turned into the right type, and I need to unwrap that. So now I've got a context. So now I need to be able to draw something on the canvas, and the way I do that is I say context.fillRect. So that means draw a rectangle that's filled in, and for some reason it takes F64s, even though canvas is like has, in the way we're thinking about it at least, is made out of pixels, so you would have thought they'd be integers, but you can draw things on a canvas that are like a sub-pixel level, and it will do like anti-aliasing between them, except we turned off anti-aliasing because we said be pixelated, so it doesn't matter to us. All right, so we just say like draw us a rectangle on that context. So we're going to build our code, go back to our browser and refresh, and yay, we drew something. It's in black. Like there's all kinds of methods you can call that change the color. I guess we could change the color, couldn't we? I again did not revise for this. I think it's set, not wet, set line color, set fill color. It's going to be set fill color. Fill or fill, set fill style. Is it going to be? I don't think it is. I think it, maybe it's just set color. Maybe it's... oh, this is why I shouldn't do things off script. Set... What's set fill style str? Let's look at our browser where we have... No, we don't have the JavaScript documentation. I don't feel like doing it. All right. So I'm not going to check the color. You can research this. All of this stuff. If you look up this canvas rendering context 2D, all of this stuff is on that Mozilla Developer Network website, like telling you all the methods you can call on canvas rendering context 2D. What you do is you set a color and then you fill a rectangle in that color. So let's just change this to be a 1 pixel thing and then another pixel that is like diagonally away from it. And then you'll believe me, hopefully, that we are controlling what gets drawn on this canvas. We refresh the page and you can see there's 2 pixels. Those are the size of the pixels, right? So because we said this whole canvas should only be 22 by 22 pixels wide, and then we said stretch it to fill the page, it just nicely moves around when we resize. Okay, so we've proved that we can draw on a canvas. So again, if that was all you were here for, like have a browser, run Rust code, modify a canvas, then we're done. But we're going to go one step further. I'm going to think about how you would write a game. And a game generally has a game loop. And so once we've done this, we'll be in a position where we've written a bunch of code that is ready for us to write a retro game by just drawing onto a canvas, because the game loop stuff's already there, I guess. So what we're going to need for this is we're going to need to call the JavaScript or browser function. It's a browser function called request animation frame, and there's a bit of jumping around that we're going to need to do to call that in a way that is nice. So where are we going to start? Let's get rid of this canvas stuff for now. Just comment that out for now. We're going to move that somewhere else later. And let's look at how to call request animation frame. So it's a function on window. Where are my notes for it? Yeah. So window has this thing called request animation frame. And the point of request animation frame is that it is intended to be used for things like games that need to be called 60 times a second to do whatever gamey type stuff needs happening. So that would be like calculate what's happening in the game, redraw onto a canvas or whatever style of drawing that you're using, and then return. And the browser will do its best to call this function 60 times a second, but if your code is too slow, or the computer you're running on is too slow to keep up with that 60 times a second, it will call you less frequently than that. And it tells you how much time has passed since the last frame, essentially. So you can like, if your game is slowing down, you can calculate the physics of your game to do a bit more than 1 frame's worth, because it's actually taken more than 1 frame to get to this time. So you can kind of smooth out any slowdown that's happening to some extent. Anyway, all of that is just to say the normal way to write games in the browser is to use request animation frame. What you do is you call request animation frame, you give it a callback, which in JavaScript would be like a JavaScript function object, and it calls that function as soon as possible, except it only does it 60 times a second. Now calling this function once doesn't set up a thing of now it happens 60 times a second. This literally just says, give me 1 more frame, or give me a callback when it's time for 1 more frame. So, we need to provide an object to request animation frame. I guess this is going to return result, right? So yeah, we need to unwrap that as well. Again, probably need to handle those errors. And we need to pass in something suitable as a callback function to request animation frame. And this is where one of the bits of the interaction between Rust and JavaScript, which so far it doesn't feel very smooth to me at all, which is what do we pass in? We pass in a reference to a JSSys function. So this is something provided in JSSys, which is like the thing that WebSys relies on. It's basically WebSys has all the stuff about the browser, JSSys has all the stuff about just JavaScript stuff. So we need... How much of this am I going to do up front? It gets a bit complicated, but I'm going to try and make it simpler to start off with. So we basically, let's have a function that we want to be the callback. So let's say there's a thing called callback, and that's going to be a Rust closure, right? So it's actually going to take an argument, which is how many milliseconds since the last time we called this, and it takes in a type called big int. And what we're going to do is we're just going to do some console logging here. Console log 1. And again, a reference to a string.into to turn it into a JS value. And we'll just say I'm in the animation frame, right? So if this function gets called, a big int thing is just the argument that gets given to the function that is called by request animation frame. If this code runs, we know that request animation frame worked, right? Because we gave it the callback, and it got called. So we can't pass in callback because it's expecting this thing called a function with a capital F that comes from JSSys, and at the moment callback is a Rust closure which implements fun. So what we have to do is wrap this up in a thing called a closure. So I'm going to overwrite the callback variable with another thing which is created by calling closure ::new and passing in what was previously called callback, like so. Now that's also not right. So we can't pass in a closure either. But now that we've made a closure, we can run. What function do we call? I think it's din. No, it's unchecked ref. We have to call callback dot as ref, I think, dot unchecked ref. Yeah. So this should be closure. I guess we have to say the exact type of it. So it's a closure that is of type a function, Rust closure-y type-y function-y thing. We're not using the argument. We're not using document. All right, we won't comment out for now, just to get rid of warnings that are confusing me. So we need to say, when we call closure new, we need to say what type of closure we're expecting to get out of it. I don't know why. And the closure we're trying to expect to get out of it is a closure, which is a wrapper. So closure with a capital C, again, is a JSSys, or a WASM. It's a WASM bindgen thing, but it's not part of Rust, right? Even though it's got the word name closure, which could be confusing, this is a closure. But this closure with a capital C is to do with this, WASM, JavaScript interfacing stuff. It's a thing which kind of represents a Rust closure, and the particular type of the closure in this case is a function that takes in a begin and returns nothing. Now we've got one of these capital C closures, we can call as ref on it. Not sure why, and then we can call unchecked ref on it, and that returns, in this case it returns, like it knows the type that's expected for request animation frame is one of these function things, JSSys function. So unchecked ref basically casts this closure thing into a function thing without checking that you're right to do that, and then passes it in. So all this is like boilerplate code for run this when that callback gets called, run this function. And I think this is going to crash. Let's try it. I think it's going to crash. This is one, like I said, one of the rough edges. Yeah. So the reason it crashed is because we tried to call a closure. Notice, by the way, it didn't log out the answer either, so it crashed before running. The reason why is an annoyingly subtle point, which is that at the end of this code, which happens almost immediately after we've made this call, callback will get dropped. This callback thing owns this closure, and the whole thing's going to get dropped. And what we need to do is basically say, don't drop it, and actually kind of hand over. Effectively, we're saying hand over ownership of this thing to JavaScript, because JavaScript has a reference to this thing now, and hopefully that means that it will look after it, but certainly we don't want the Rust to delete it. So we kind of just, I don't know if we're leaking it or it's just being given to the JavaScript to be looked after, but we're no longer responsible for cleaning it up. So I think once I do that, it should work. Yeah, so it says in the animation frame. So our callback got called. So all this adds up to, if you want to make a callback in, if you want to call a JavaScript function, which is what this is, from your Rust, and provide a callback, which is Rust code, there is this pattern, which is, here's the actual function, or closure, wrap it in this capital C closure thing, and then call asRef.unchecked ref to turn it into a function, and then make sure that we don't then delete it. And this is one way of saying don't delete it. All right, so we've managed to request animation frame, but you'll notice that, like I said, it's only called once. There's no, like, if this was called lots of times, Firefox would be saying it's been called 17 times, so there'll be a number here. So request animation frame doesn't like immediately give you 60 frames a second. It just gets you the next frame in that setup. If you want to have 60 frames a second, you need to call request animation frame from somewhere else. And the natural place to call it is from inside your callback. And then it gets really confusing, because what we want to do is we want to say window.request animation frame and pass in callback. Well, we're in the definition of callback, or like, maybe you should have different names actually. Maybe this should be called, I don't know. Let's rename this to CB. But yeah, so we want to pass in CB here. And at this point, we don't even have CB. And we certainly can't use it. Like, Rust won't let us have a reference to a thing that is currently being defined, or it's one of its prerequisites is being defined. So this gets even more convoluted. But the way to handle this, or one way to handle this, is to have an RC, so a reference counted pointer. So we need that. I think we need it. Yeah. So you have a reference counted pointer thing, which starts off empty, but when this code gets called, will have been filled in. So let me try and explain. So we're going to have a thing which we'll call it on frame. And I'm going to call it ref cell, because in a minute we'll see that it's actually going to be a ref cell. And it's going to basically hold on to our callback, which is the CB thing. Is that right? Yeah. It's going to hold on to this CB thing for us. So we might say, like, it starts off as nothing, and then later on it gets filled in. So we could do that. So we can say, how do you do that? Yeah, you say, so basically, let's bring in RC. So basically, we want a reference counted thing to say this thing won't get deleted until people have stopped referring to it. And then inside there, we want an option, but we need to be able to change this thing later. So it has to be a ref cell, because ref cell is the way of giving ourselves the ability to change something even though it's an immutable thing. And I can, because the ref counting like multiple people are holding onto a reference to this thing, so it needs to be immutable, but then we actually need to be able to change it. So ref cell is the way of escaping from that trap by saying, I want something that's changeable and I want you to check at runtime. That's allowed instead of checking at compile time. By the way, you could do an arc of a mutex, but in this case, there is only one thread happening in our JavaScript. Normally, there is only one thread, so we can use an RC and a ref cell, and it works fine. Anyway, all of that is just waffle to say, if you understood none of that, you're just going to have to copy this code. And basically, the way it works is we make ourselves a ref cell, a reference counted pointer to a ref cell. We put nothing inside it, and then here we put something inside it. Actually, it should be maybe even here. Well, in a minute, we'll delete this line, by the way. We won't do it quite yet. We'll explain why. So we call this replace on this ref cell. Is that going to work? No, because it doesn't know what a ref cell is yet. We'll comment out this because this line's not ready yet. So once we've created CB, then we can put CB inside this ref cell. So basically, this ref cell is going to stick around. All right, so we'll handle that in a second. This ref cell, its purpose is to mean that while there are references to the thing inside it, it won't get deleted. So that's the purpose of the RC. The RC is to say, while someone is holding on to a reference to this thing, or holding on to a copy of our RC is really strictly the thing, we don't delete it. And then the ref cell is saying, have something in here that looks immutable, but you can change it. And this code is saying, now please change what's in that ref cell, which is going to hang around, to be, instead of none, it's going to be some, and then our callback. And we, for a second, won't do this bit. And now we've got the situation where, don't forget it. So instead of forgetting it, we're going to hold it in the RC. So that was my explanation for why forget's gone. Actually, that means probably this is okay. It was that bit that it was complaining about, I think. Yeah. So we're calling request animation frame once and saying, here is your function to call, which is actually just CB. And then we're putting CB into this ref cell, or into this RC of ref cell, so that next time when the callback actually gets called, which, so by the way, none of this code inside the callback, inside the closure is actually executed yet at the point this code runs. So basically, early enough, we're doing this replace so that now the ref cell does contain this callback. So now when the callback gets called, the ref cell is going to contain it, and then we're going to be able to get it out of that ref cell in this closure to use it. But let's just make that doubly clear. So instead of saying please call the callback by passing in the callback, what we can actually do is put the callback into the ref cell before, and now when we ask for it, instead of providing CB directly, we can now provide the ref cell and say, I think it's borrow we want, like so. Is that working? It's a, I guess, do we need it as ref anymore? Let's just do unwrap on this. I think we do need as ref. Yeah. So we're saying get the we need it as ref before we unwrap, I think, because we need an option of a reference. Yeah, but now we can't do that. I think we need another asref, right? Okay, all right. We found the incantation. So again, if you don't understand any of this, just copy it. But yeah, basically, we don't need this. It's making the code more complicated. But it makes it absolutely clear to me that before we ever call this callback, then this on-frame ref cell thing has been populated with something, because it started out as a none. The reason we're starting out with it as a none and then filling it in later is we need to fill it in with something we haven't created yet, but we need to use it before it's been created. Now, when I say that, what I mean is we need to mention it before it's finished being created. But actually, as I was saying, this code won't get run until we call this line. And at that point, it definitely will have been populated with something. So it's okay for us to assume it exists in here. So back to this, we can say request animation frame and and then I think it's going to be pretty much the same incantation as this. So maybe there's a way we could share this code, but I won't bother with that now. So now what's it complaining about? All right. So now it's complaining that we're using on-frame ref cell, but I don't actually know what it is. So I need to declare it. So I need to say it's an RC of ref cell of option of what is it, closure, like that. Is that right? Oh no, the closure is a closure of din fun of big int. I think that's right. Yeah. Now. Oh yeah, okay. Now it's complaining. Okay, so let's continue talking. So we've got that right, I think. Whoops. But we need to make this work, we need to think about what this closure is borrowing, because the point is this closure is now going to live longer than this code. And so its reference to window is going to get deleted when this block of code finishes. But it needs to actually hold on to its own copy of window. So what we need to do to make this work is we need to make a clone of window. Oh no, hold on. Yeah, we do. Yeah, we need to make a clone of window. Like so. And then use the clone of window inside here, and not take a reference to it, but move it in. So now this is a move closure, because we need to take this window clone thing and move it inside so that every time the callback needs it, it's still alive and there and ready for us to call request animation frame on it. And it's also complaining about on-frame ref cell, because on-frame ref cell is being used, but we've already now this is a move closure that we've moved on-frame ref cell inside here, so we can't then use it later. So what we need to do is another type of clone. So we need to say on-frame ref cell clone, I guess, equals. Now, the way I write clone when I'm calling clone on an RC or an arc is like this, because I find it confusing. I think someone somewhere recommended this. There needs to be a reference to that. I'm pretty sure I didn't make this up. When I'm saying I don't actually want like a deep clone of this on-frame ref cell thing. I just want another reference to it. I might try and make that clear by saying RC : clone instead of, I could have just done on-frame ref cell dot clone, but then it looks like I'm deep cloning it in some way, which, by the way, here this also looks like that. Actually, it's not. But in this case, it's an actual method on window. But it's what you're actually cloning is just a shallow reference to the real window that lives in the browser. So it's a similar issue. But anyway, in this case, we get to say RC : clone to make it clear to anyone who's looking on that we're not making some deep copy of this thing. We're just asking for another reference to it, which we're then going to use in here. And with any luck, that will make the errors go away. Hey, it looks good. It looks good. Okay, so where have we got to? We've done a load of really confusing boilerplate, which basically says, I need a thing to hold my closure in. And now here's my actual callback. Inside my callback, I want to request another callback. So I give it my thing that's going to hold a closure in, or I grab the closure out of the thing that holds the closure. And I trust that by the time we get to running this code, there will actually be something in there. That's what this unwrap is about. So we could handle the case where there's nothing in there for some reason. But I happen to know there will be something in there because as soon as I've made this callback, I wrap it in a closure and then I store it in my ref cell. And then to kick the whole process off, I call request animation frame and pass in my closure. By the way, I could just like immediately call the closure instead of calling .request animation frame, but it seems like the right thing to do is call request animation frame here. All right. So all that confident talk aside, let's see whether the change we made actually works. So what should happen if it works is that instead of calling this closure once, this should get printed 60 times a second because we're calling this closure 60 times a second. So let's see if it works. It does look at this number shooting up. We are calling that code 60 times a second. So that's great. But we're not doing anything interesting inside there. So what I would like to do is I'd like to call some game code every time that callback is called. And I would like to then make sure that my game code is not called 60 times a second because I want my frame rate in my game potentially to be like 10 frames a second, something like that. Certainly potentially lower. You might want other things here like your physics runs 60 frames a second, but your actual visual update only runs 10 frames a second or something like that. But I'm just going to do something really simple. Anyway, the first thing I want to do is instead of just logging something, I want to call out to some other code in a separate place, which is for the code for the actually doing the game, including that frame rate business. So I'm going to imagine that there's some kind of thing exists, which is like some kind of struct, which I'm going to call game. And yeah, I'm going to need that wrapped up. So first of all, I guess let's make the game. So let's make a file called game.rs and make a struct in here called game. And I guess there's going to be a function in game called, I think I'm going to call it onFrame. And it will, in a minute, it'll take some arguments and stuff like that, but we'll get there. All right, so let's add that to our actual project. So what that did was it added a mod game, and it means that this thing called game exists. It's not used for anything yet. In fact, let's get rid of this stuff because I don't think we're going to need it because it's going to go inside game. So when we start, so this function gets called, this is like our main method, right? Like the JavaScript just calls this and lets us go and doesn't do any more work after that. So at the start of our main function, we're going to create a thing which we'll call game. I guess we're going to have let's have a new method on game, shall we? So bring in game and then add a new method, function rather. And all right, it's actually generated the thing that we might have wanted apart from making that private to the crate. So now we are able to create a game. And what we want to be able to do is call a method on game in here, right? So we want to say game.onFrame. In a minute, we'll pass some arguments in, but for now, it's not. So the problem is, well, first of all, onFrame should be a method. So that looks like it's going to work. But the problem is we're going to want to call there are going to want to be other callbacks that also call onFrame. And so the most obvious thing is when the user presses a key or some other event needs responding to, we're also going to need to call methods on game as well. So let's demonstrate that by actually setting up some kind of key handler. Yeah. So again, we're going to need the same kind of business with a callback to do this. So it's going to get complicated. So I feel like this is getting a bit messy, and I want to put this into a function. So let's put this into a separate function. No, I want not extract into variable, extract into function. Wonder why it won't let me extract a function, because I've done something weird. So let's manually do it and see what happens. So we're going to call this set up animation frames. It's going to take some arguments, which we'll deal with in a second. And it's just going to be all of this stuff. It looks reasonably independent. I wonder what it didn't like. No, it's going to need game. It's going to need window. All right, so pass in game. And for now, I guess we can pass it by value. But that's demonstrating that something a bit funny is up with this, like passing the game in like that. And yeah, we've got window. So by the way, we wouldn't have window. This is a good example. We wouldn't have window available to import if we hadn't done this and added it as a feature in WebSys. So whenever you've got some bit of the web API that's not working for you, you probably need a feature in WebSys, and then it should just magically work. So we're going to call setup animation frames, pass in game and window. Seems to work. Double check it actually works still. In the animation frame gets called lots and lots, so we're all good. Okay, so what's the point of all this? The point of all this is right now we can just pass in game to set up animation frames and it works, but what we're going to want to do is also set up a keyboard listener. And we're going to want to pass in game and window, probably went to into that. Doesn't look like we need document yet. So we can have a function called set keyboard listener. But look, it's taking ownership of the game as well. Well, that didn't work. And it's gonna need not just to take ownership briefly, or like we couldn't just pass in a reference to that game or something like that. It's going to need to actually do stuff with that game. So let's briefly comment this out. It's going to need to call methods on game, potentially mutable methods and things like that, because like when keyboard events happen, it's going to change what the state of the game is. And similarly, this code might also change the state of the game because it's going to progress a timer or something like that. So game is not going to be able to just be a raw thing like that. What I'm getting towards is we're going to need to wrap this up in like an arc mutex setup so that it can be accessed simultaneously from multiple places. Even while one person's accessing, another person might try and access, so we won't need that mutex to make you wait. So let's demonstrate this by talking about like what's going to be done inside the keyboard listener, and then we'll see that it needs that wrapping up in that arc of mutex. So what we're going to do is we're going to make ourselves another closure. We'll call it on key down. And it's going to be a closure with a capital C. I've typed in fun of a function that takes an event. An event again it's a JavaScript or DOM thing concept which is being provided by WebSys. So this is going to be a closure new with some kind of Rust closure inside it, which is again going to be a move closure for this to work. And it takes an event, and that so basically when keys get pressed, okay, import event. When keys get pressed, and it's gonna this closure is going to get called, and it's going to pass in an event which tells you what key was pressed. So we're going to do something like, we're going to call an onKeyDown function on the game. And we're going to pass in. Right, so let's have the game function take in a key down event. So we've been given this event, which is just a type event, but we can do din into, again, unwrap. And the key down function on game is going to take, this should be something like event. It's going to take I think it's called key down. Oh, it's going to called keyboard event. Now we called this on key down because we're going to set, in a minute, we're going to say only listen for key down events, but you don't know that yet. All right, so it's going to take in a keyboard event, and then we're going to be able to do something with that keyboard event to figure out like what key they pressed. So we made this closure, but we haven't done anything with it yet. But what we're going to do with it is we're going to add an event listener. So we're going to call a method on window. Oh, by the way, I don't like how this is wrapping, so let's quickly make a Rust format.toml file. And that should have my usual stuff in it, which is this. Max width 80 is the thing I'm particularly thinking about, but it also makes my imports the way I like it, and it turns on wrapping on comments. So now when I save this, it's going to wrap nice. That's much nicer. All right, so back to what on earth we were doing, which was window.addListener with callback. The event we're listening to is the key down type of event, and the listener is going to be this familiar pattern that we already had of onKeyDown.asRef.uncheckedRef. That's just the incantation to turn a closure into one of these capital F functions. And we need to do, and this time we will do forget. So we're only going to, this code only runs once, and it makes a closure. It adds a listener saying, please tell me when a key got pressed. And so we don't want to clean up this closure. It might get called at any time in the future. And there's only one of them. So we'd fine to forget it, even if that means that it genuinely leaks, like it's only one thing. I think it means that JavaScript is somehow responsible for it getting cleaned up, so it won't even leak. So let's just print something out when they press a key, shall we? So we can do something like console log1 reference to a thing dot into, and we can just, I think, print out the event maybe. I don't know. This should be the format macro. We're using the console module. Looks like we can't do events, so we'll do, I think there's a key. Or key code. I think the key code is what we want. And let's print out like key colon blah, like that. All right. Compile all of that, see what happens in the browser. Should still be doing the animation frame. No, we stopped the animation frame stuff. We got rid of it. So let me just make that clear. It was doing some other frames from last time. So now it's going to check for key presses. And when I press the up arrow, it prints out 38, 37, 39, 40 for the different arrow keys. So that key code is going to be how we tell what key the user is pressing. And it did work. So we did end up inside this callback, and we called a method on game, and game received that and printed out what key you pressed, which is cool. But what we haven't handled yet is the fact that set keyboard listener and set up animation frames both take ownership of game, so that we can call these mutating methods on game, because on key down should really be, let's tidy this up a bit. To make this clear, this should be a mutable reference to self, and so should on frame, because self definitely might change. There are all kinds of state in the game might change if something happens. You might remember which direction you're facing. So they both need to take mutable references to the game. Now, this is now sad because, and this is already sad because, is it because game is not mutable? Maybe? Not sure. But anyway, so I don't want to get into exactly why that compile error looks like that. Instead, I'm just going to jump to the correct answer, which is, in order for this to work, where we've got a keyboard listener which could fire at any time, wanting to modify the game, but also the animation frames are firing 60 times a second, so they could easily overlap with one of these listeners. They also want to modify the game, so we need to lock up the game behind a mutex. So the way we do that is, instead of just creating a new game, we create a new arc, which contains a mutex. And what that means is we can give lots of people these arcs, which all refer to the same underlying game, but because the mutex is there, they call lock on that mutex in order to be able to modify that game. And if someone else has already got that lock, they just wait until that person's finished. So set keyboard listener is not going to take in a game. It's going to take in an arc of a mutex of a game. Now you may be wondering, why am I doing all of this quite specific stuff? And it's because I have a specific goal in mind, which is to have enough framework created that in the next video we can just have fun making a game and don't have to think about nasty framework stuff. So the way you use something that's stored inside a mutex, the arc doesn't kind of bother us because we just dereference past that, and inside we find this mutex. And then the mutex has this lock method on it to say, I want to modify this thing, please block until I can. And then that might go wrong. So that might go wrong because if someone else was holding the lock and then they panicked. So we're not going to panic while we're holding the lock. So we're okay to just unwrap and say, we don't believe anyone has panicked while holding onto the lock. Then we can call a method on the underlying game, which might mutate it. So we've made that error message go wrong, but also we've made it possible for us to call set up animation frames, and so long as that also takes in an arc of a mutex of game, then we'll be allowed to lock it, unwrap because no one's panicked holding the lock, and then call a mutating method on it. And that will all work except for one thing, which is we've already passed in, no, we won't have a rest break, thank you. We've already passed in game to set keyboard listener, and now we're passing in game to set up animation frames. But it's okay. We can, again, using my style of on clone, calling clone by its more fully qualified version here, in order to make it clear that we're not actually cloning game. We're just making another reference, counted reference to game. So we make a new arc, but it's pointing at the same underlying game, pass that into set keyboard listener. And we pass in the original arc into set of animation frames. And with any luck, the animation frames will be able to run at the same time as us listening for keyboard events. Let's try it. So in animation frame is happening, but also when I press a key, it registers and it doesn't crash because they're accessing the same object at the same time. So it looks like so far everything's working as we hoped. Let's get rid of some of our... Well, we can leave the logging in and we don't get warnings. All right, so where have we got to? What we would like to do is just a couple more things. We're basically there now. What I would like us to do is to actually draw some stuff when the frame happens. And also talk about that frame rate thing. That's the other thing I think would be good to do. So first of all, let's draw some stuff when the frame happens. And for that, we're going to need the document. So I guess when we create this should be like this, shouldn't it? I always like my new method at the top, my new function. All right, so in order for us to be able to draw stuff on the canvas, we're going to need, I guess the game maybe should hold on to the canvas rather than a document. Should we do that? Let's have ourselves pass in to the new function a canvas and hold on to that inside the game. Like so. And that means that this code actually lives outside. Lives back where we were. So when we create a new game, it needs to be based on a document. And in order to have a document, we need a window. So let document, we write this and I got rid of it. Let document equal window.document .unwrap and warp. I type that quite often. Okay, so now we've got ourselves a canvas which we can pass into the constructor of game. And game now has a canvas. And then inside this, we can say self.canvas, blah, 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 blah. We need JS cast to be available to us. I guess we accidentally imported that without noticing last time we did this. All right, so now we've got a context every time the frame happens. By the way this works with the canvas is we don't want to store this context. This context needs to be got briefly just to do a bit of drawing and then got rid of. So we need to create a new context every frame that we draw. That's my understanding anyway. Pretty sure it's right. So now you have to trust me that this is being drawn repeatedly, but every time this and the animation frame thing is logged, we're also drawing onto the canvas. And we can make that a little bit clearer by doing our logging in here as well. Let's do our logging in here. So where was that? Okay, so here's where we logged in the animation frame. Let's do that inside the game. So let's just say inside on frame. Double check that really works. Yeah, so inside on frame is getting called. Oh, it's really confusing when log messages from the previous load of the page get displayed. But anyway, you can see that it's inside on frame is being printed lots of times. So this game method is getting called lots of time, this on frame method. So we're nearly there. What we're going to do is we're going to handle the frame rate stuff. And maybe we could draw something more interesting. Let's do something with directions and then we'll really be ready. Okay, so what we haven't talked about yet is what gets passed into request animation frame. So request animation frame, as we saw, which I did, but I didn't go into, you give it a callback, and that callback takes a in the DOM world, in the DOM documentation on Mozilla Developer Network, it says it takes a high-res something timer. No, high-res something time. Basically, it's a number that's more accurate than the standard JavaScript number, which tells you how many milliseconds since the last frame. But then in WebSys, it's coming in as a big int, which is another class that's defined in that DOM world in the browser, and I guess maybe they're equivalent in that world. But what's really weird is that I saw some very strange behavior with this, which was that even though the type in the Rust is big int, what it's actually coming out as looks more to me like a float. It comes in as a number that is a decimal, not an int. So the fact that it's a big int here is very odd. But so the way I worked, I spent some time trying to figure out this thing, and maybe it's just a glitch in the particular version of WebSys that I'm using, or like it's a bug that will later be fixed or something. The way I found to work around this was big int has a method on it called I had this written down. Where is it? Yeah, called unchecked into F64. Unchecked. Oh, what? There should be TS dot. Unchecked into F64. And what I found was that if you converted this thing, which is supposed to be a big int, into F64, in this unchecked way. So basically this means effectively generate the equivalent of JavaScript just saying that, this definitely is a number, whatever you think it may be. Then it seemed to work. I don't know if that's the exact right thing to do, but let's have on frame, take an F64, like so, to say how many milliseconds was it since the last time I got called. And what we'll do is just print that inside here. So let's make this be the format macro to do this, and print out the timestamp. I guess we should say TS equals. So when we run now, it's going to print loads of log messages instead of just wrapping them all up into one, because they've all got the time in them. And that can get rapidly pretty distressing. But you can see these numbers are not integers, so it's very confusing. But anyway, I'm pretty sure that is like number of milliseconds since the last frame. So I think it's behaving the way we expect, even though the types seem somehow wrong. And again, this is as soon as you step out of the nice, clean, rusty world, all bets are off. And so weird typey wipey stuff like this happens. All right, so there you go. Not printing anymore, but still running. So that means that we've been told how long it was since the last frame. Now, all of this is in aid of the fact that, because the request animation frame tells you how long since the last frame, we've now got this through into a sensible format, F64. What I would like to do is actually only do something 10 times a second or whatever instead of 60 times a second. So what I'm going to do is I'm going to put this stuff in a new function, which I'm going to call step, which takes mutable reference to self, but nothing else for now. And we're going to call step, but only after the right amount of time has passed. So I'm going to say something like if TS is greater than this, for some value that I'm storing called next frame TS. Then we call step. So if we've got into the next frame, call step, but also we're going to update the next frame timestamp to like some number of milliseconds after the last one. So here I'm saying 400 milliseconds later. So basically, imagine there's this thing called next frame timestamp. If the time has gone past next frame timestamp, this is not quite right, is it? Oh, well, no, it is, because if we look at the numbers that are coming out here, or before I stop printing them, they are, okay, so I was wrong. It's not the amount of time since the last frame. It is some kind of clock telling you how long, telling you what time it is. All right, so, I was saying the wrong thing, but this code is going to do the right thing. So we need to have this field called next frame TS, which should be an F64. And then we need to initialize it to, let's say 0. And then when the time comes in, it's going to be bigger than 0. So it's going to do this first time. It's going to call step, and then it's going to say the next frame should be in 400 milliseconds after this time. And just to check that this is working the way we expect, let us make the step method print something. Can't print the timestamp, but we can, because we don't have it, but we can just print inside step. We don't care that we're using the format macro uselessly here. So let's try it out, and it should now be saying inside step, and it calls, but look how that number is going up slowly, because it's only every 400 milliseconds. So now we're basically prepped for a game that every 400 milliseconds, and we could make this be some kind of FPS calculation instead of just 400 milliseconds. Every 400 milliseconds, this step thing gets called. We have a mutable reference to self that we can mess about with, so we can update our game state in some way, like what direction is the player facing. And we know how to draw stuff. Now, this is a bit inconvenient. We probably want a method for draw a specific pixel if that's what we want to do at a certain color or something like that. Or even you can do things like draw images onto canvases and draw more complex shapes and things like that if we wanted to. So there might be some more stuff we do in terms of framework that is to make dealing with the context less painful. But we've got a framework for all the nasty callback stuff. So we're writing just really nice pure Rust here. Okay, and manipulating the DOM APIs, which can still get a bit painful, but pure Rust that we know is run every 400 milliseconds. The last thing I wanted to do was just interpret this keyboard event into some kind of direction. And maybe, do we store the player direction? Yeah, and what I wanted to do, the last thing I wanted to do is just remember what direction you're facing. And I think we might write a snake game next time. So we need to remember what direction you're facing. So I'm going to say that there's a property on the game called dir, and it's going to be able to do things like up. So let's imagine that dir, let's not imagine, let's make dir exist. So we're going to edit a file called dir, and it's going to be an enum with these values. Now, I had them in a specific order. I had them in order of the key codes for them. So left, up, right, and down. Now this should exist as a thing. Now when we try and use dir, it should offer to import it for us, which it does. And now it's not used for anything. So what we would like to do is whenever you press a key, we would like to, I guess we could say what direction you're facing, couldn't we? But instead of logging for now, we're just going to say self.dir equals. Well, that's not quite right, because the key might not be, might not represent any directional key. So we're going to do a match on event dot. I think it was key code, wasn't it? And there's as we saw printed out earlier, 37 means left, so we can update self.dir to be left, like so. So now when you press 37, we set the direction to left, and 38, 39, and 40 also represent valid directions. 39, 40, so the directions are specifically up, left, up, right, and down. And then we have to handle a case of when it's some other key, and in this case, it's really trivial. If you press some other key, we don't want to do anything. And I feel like at some point we should print out what the dir is, right? So maybe we could do it here to demonstrate that this actually is persisted. So I don't think we're going to be allowed to. Can we debug print this? If we do colon question mark and make dir be debug printed like this, #derive debug. Now we should be able to debug print our direction every time step. So rebuild, back to the browser, refresh. And look, our direction is up, but when I press the right arrow, our direction is right, and every frame it prints out again, the direction is right, and I go down, and it prints out, the direction is down. So that looks to me like that's working. So I'm going to triple check my notes whether there was anything else I wanted to cover, but I think not. So I think the only thing to talk about is just to go over what we've done and then let you know that I will push this code to Codeberg and put a link in the show notes so that if you want to go over what I've done, I'll leave it like this as just WASM game, and then next time we'll have an identical project which we will build probably a little snake game based on this framework that we've created. So quick review, what have we done? We did a load of WASM pack setup, which gave us some very simple Rust code and a bit of stuff in cargo.toml. And when you do WASM pack build minus target equals web, it creates all of these files, JavaScript TypeScript, etc. files. Then we wrote a little bit of JavaScript to import that module that got created and the functions from it that we wanted, call that init function, which you have to do, and then call our real function, which was generated from Rust. So yeah, so wasmgame.js has this, inside it has this start function, which calls a WASM code, and that WASM code is what's been created by compiling our Rust code. So our Rust start function looks like this, and it can use code from like the DOM and stuff like that, because we have this WebSys dependency and all those you remember the WebSys features that we asked for, like please give me window and please give me document. Now that I've got document, I can call this function, this method document, to get hold of a document, and it gives you like the type of it is capital D document. And you can use all these other functions which you'll recognize if you've done JavaScript programming in the browser, like getElement by ID. They've been renamed to look like Rust functions, but you're really calling JavaScript functions. And then we can do very Rusty things, making a struct of our own design, wrapping it in an arc and a mutex, because it's getting used from multiple places at once. Like all this coding is like callback based, so you have to accept that there are going to be some locks or something that means that even if the keyboard processing code gets called in the middle of us running an animation frame, we just try and get the lock and wait until it's available so that we can do our keyboard work when the animation frame work is finished. And that's because this stuff is all happening, events are firing all over the place, then we just need this kind of locking if we're going to work this way. Maybe we could do some kind of Elm architecture type thing where things are more it's more straightforward what order things are happening in. But if we do kind of standard browser type programming, but just code it up in Rust, we are definitely going to need to handle the fact that two things can be happening approximately at once. Anyway, we then asked the window, please give us a listener, so that calls our callback every time the key down event happens. And we had to do this dance to wrap up a Rust closure, which is this little bit of code here, in this capital C closure, so that we can do this unchecked ref to convert it into this capital F function object, which is what the listen thing expects to be passed in as its callback. And remembering to forget it, otherwise we'll delete that callback that closure straight after we made it. So when they try and call it later, it will be gone. Then we did the really complicated stuff to handle the same kind of stuff, except with this additional feature that we need to call request animation frame and pass in our callback when we're in the middle of defining our callback. We're defining our callback, but we need to call request animation frame and call our callback. So the way we did that is by sticking our callback inside a ref cell, an RC of a ref cell, so that it starts off empty, but by the time this code actually gets run, it's filled up. So we can happily unwrap it and know that it's really there. And this is the first time we kick off. So basically, request animation frame is because of this kind of recursive sense of we need to call request animation frame inside the callback that was called by request animation frame if we want this thing to keep happening. That's a bit confusing, and particularly the way Rust interacts with that type of code is particularly confusing because it's Rust doesn't like a reference which ends up referring to the thing itself in that odd kind of way. So we needed this thing of like initializing it empty, and then later we know it'll be filled in. Anyway, like I said, if that's confusing, just have a look at my code when I've uploaded it to Codeberg and just copy it. And the whole point of this whole video is to write all this complicated code so that we end up with only having to think about this relatively simple, very much just Rusty code, which is what game is. All it does is responds to events like a frame happened, or really, even probably we don't even need to modify this code now. It's like that just handles the fact that an animation frame callback happened, and then turns it into a nice slower thing of every 400 milliseconds we call this. Anyway, point is this code only has to deal with, I need to do another frame, so I better draw something on the canvas, I better update my internal model somehow, and also other events like a key got pressed. So I need to change which direction I consider the player to be facing. And so when we're writing a game, we'll mostly be in this game module and not worrying too much about especially the callback stuff. We still have got DOM stuff that we're doing in here. Maybe we could factor even that out so the game is just completely abstracted from the browser. And that might be nice and might not. Yeah, what was I going to say? So I think we're there. We've got a frame. Oh, that's what I was going to say. If you're really lucky, I'm going to try and write a blog post that explains all this stuff in written form, because consuming this kind of material as a video may not be, it's good for kind of getting a feel of it, but it's not good for when you need to look it up later, when you actually need to do it. So with any luck, I'll also write a blog post explaining some of this stuff, and stick that up. Hope you enjoyed it. I hope you'll be back for writing a game, maybe a snake game if we're really lucky. Next time, probably a shorter video, because I bet this one's turned out way longer than I originally thought it was going to be again. But yeah, I hope you enjoyed it. Let me know if you did. Let me know what little game you'd like me to write. And please make it little. And see you next time.